Okay, so your printed circuit board is basically the physical representation of your schematic in the real world. Um, in a similar vein to how the schematic is composed of, schematic symbols, or all your components are represented by schematic symbols like this connector and this fuse and this resistor. Um, Components are represented on the PCB by using PCB footprints, or the footprint that the component takes up on the board. Um, so this would be the footprint for that 2-pin connector. This would be the footprint for that fuse. And if I zoom in on resistor R2 here, the resistor that we were looking at earlier, this would be the footprint for that. So I'm just going to press Shift S on my keyboard twice so we can isolate the top layer of the board to see this footprint better. So all of your footprints are going to have things called pads within them. And basically, pads are points of electrical connectivity, or the points on the board you actually connect the component to, so it can interact with the circuitry on the board. So these pads here, these two red rectangles, are surface mount pads. So what you do is you would place your resistor on top of these and then solder your resistor to the pads. The dimensions of these pads you would get from the manufacturer datasheet. Um, since these are resistors, and resistors are highly standardized components with only a few different package sizes. Um, Basically, all the footprints for um, most of the resistors you are going to use are already in your libraries, so you will never have to make a footprint for a resistor. But for something a little bit more complex and variable, such as like an integrated circuit, um, integrated circuits come in so many different package sizes, and we only have a few of them in our Altium libraries. You'll likely be making lots of footprints for components like these. Um, yeah. So in a similar vein to how your schematic symbol has two different parts, the graphical element and then the properties that come with it, um, your footprint has like the copper pads to it. But also, if I press 3 on my keyboard to go into 3D view, we also like to place a 3D model of the component on our PCB footprint. So as you can see here, these little squares here, the surface mount pads, these are the exposed copper on the board. And you can see there's a 3D model of an 0603 resistor placed on top of these pads, and it's pretty evident now that or how you would solder the resistor to these pads. But we also have 3D models for other components like this LED here, and this 2-pin terminal block, and there's lots of other stuff. It's good practice to make or to include 3D models in each of your footprints, because number one, it looks pretty cool when the board's finished and you get to see everything put together. Number two, it acts as kind of a guide. If you're assembling the board, you kind of know how everything's going to fit together, and how each component should be oriented on the board. And number three, especially for designs where you have lots of tall components, such as this boost converter where we have this big inductor here and these tall capacitors, it gives us an idea of how much space we need to make in the rover to accommodate this board. So that's kind of the gist of PCB footprints. And now, when you make footprints, you make basically PCB library files. So all your footprints are stored in these PCB library files. So this file here is res, stands for resistor, and then 0603. So this is the footprint for an 0603 resistor, of course, and then .pcb libs the file extension. This basically provides you like a workspace to actually create these component footprints. So as you can see, I can like drag the pads around to place them wherever I want. And if I press 3 on my keyboard, I can also move around a 3D model as well. And I'll talk about this more in depth later, but this is kind of where you would make your footprints if you're going to do one. If we go to our magical Excel file here, basically for all of our components, you'll see that there are two columns called footprint reference and footprint path. Your footprint reference is basically the name of the footprint, so this would be res 0603, and then your footprint path is going to be the name of the file, so res 0201.pcblib would be the file name for your 0201 resistor footprint, right? So this basically tells Altium, hey, I know we have like this schematic symbol for the component, but like when we're going into PCB mode, this would be the footprint for the component, or what it would look like in real life. So essentially, we're basically just linking the footprint to the schematic symbol here to like create the full component, so we can represent it in schematic world and in PCB world. So when you're ready to transition and do board layout, Altium is going to have all the correct footprints for your components all there, so you can place them on the board and then route traces around them, connecting them together, which is awesome.